type 1 factor. Now, we only know one way to factor for only one certain kind of polynomial. There's all different kinds, but let's review. When you are given a polynomial and you're told to factor it, the first thing you do is a type 1 factor question, which is there a greatest common factor? So let's look at the numbers. 2 and 4, 2. X squared and x. So our greatest common factor is 2x, either in your head or explicitly. Divide by the 2x. So what do I get left here? X plus 2. I verify by multiplying. So let's multiply back. Do the distribution. 2x squared plus 4x. Matches. So it's a way to check, did I do this right? You guys seem pretty strong with this, but are there any questions on type 1? I think we're ready for the next stage. Type 2! And I'm glad Derek brought up that he was noticing some patterns in the other question, because we're going to go back to that pattern. We're basically going to be looking for binomial squares. Well, first of all, what's a binomial? It's a polynomial with two terms, right? Two monomials. And what's a square? Give me an example of a number that's a square. Perfect square. 4. Right? How about this? Is this a perfect square? What's that perfect square of what? Not sure. What's the root of that number? He's not sure. Okay, he's working it. He doesn't let me know. But how about x squared? Is that a perfect square? What's the square root of x squared? X, that's a perfect square. How about x to the 10? What's the square root of that? X to the 5th, right? So we can have variables that are perfect squares. But we're going to revisit this pattern. Remember the sum and difference pattern? A1? Okay. So remember what happened if you do a FOIL on this? We had the first, we had the outsides, we had the insides, and we had the lasts, and our outside insides would cancel out. So when you have a sum and difference pattern, same thing except it's a plus and a minus. You just multiply the first, multiply the last. Always going to be a minus, right? Because a plus times a minus is a minus. Yes? So let's review. So if you have x plus 3 times x minus 3, what's that going to be? X squared minus 9. Good. If you have that, careful with this one. 2x minus 5, 2x plus 5. What do you get? 4x squared. Oh, awesome. Yes, 2 times 2 is 4. Don't forget to do that one as well. Great. Now what we're going to do is we're kind of going to work backwards. So if you're given a polynomial that looks like this, looks like what? A perfect square minus a perfect square, that means they're going to go backwards to this. So, what factor? So if you have an x squared minus 16, what factors do you get? So what you do is first make these two little guys here because I have a perfect square minus a perfect square. Is that yours, Emma? Yeah, what do you think that's going to be? Excellent. How'd you get that? Great. Take the square root. Take the square root. Right? What's the square root of x squared? X and x. What's the square root of 16? Negative 4 and 4. Yeah. Oh, great question. Could I have done this instead? Yes. How come? Which property? Which property? Which property? Start to see. Property of multiplication, right? I can multiply in any order. Either one of these is the correct factorization of that. And that's type 2. So how does it work? If you have a perfect square minus a perfect square, build 2 parenthesis sets, take the square root, take the square root. That's what goes here and here. Plus minus or minus plus. Yeah? Oh. If it's a perfect square, if it's not that, it's not a type 2. So the pattern that type 2 looks for is it a perfect square minus a perfect square? And if I have it, it's a sum and difference. So let's see here. That's just where it's got to say yes. If you have the difference of perfect squares, use the sum and difference special product. So let's do one example here. Why it's the same one, right? So when you see a perfect square minus a perfect square, in your brain you go ding ding. Oh, that's a type 2. In fact, my algebra teacher used to call these bell ringers. There, and thank you, Bell. Oh, how awesome was that? I could not have timed that better. Yes, it's a bell ringer. Thank you, school. Not because it's something you do when you walk in the room. That's what we tend to call bell ringers. Mr. Mandel used to call this a bell ringer because he wanted you to recognize right away perfect square minus perfect square. I mean, that noise we just heard, that should go off in your head. Saying, whoa, whoa, special case. So when I see them, you open up 2 parentheses. You take the square root of the first guy. What's the square root of y squared? Y goes there and there. What's the square root of 16? There. 4 and 4. And then either put a plus minus or put a minus plus. Either way. Let's try this guy. Is this a bell ringer? Is it a perfect square minus perfect square? Oh, I wish I could get that to ring again. Open up 2 parentheses. Square root of x squared. Square root of 49. Plus minus or minus plus. Either way. Is this a perfect square? Is that a perfect square? So we open up 2 sets of parentheses. Careful, careful. Square root of 4x squared. 2x. Square root of 25. Let's do negative and plus. Yep, we can go either way. Okay, this one on your paper says advanced. And then, what's that? Let's see what happens here. So x to the 4th minus 16. Is this the perfect square? Yeah. What's the square root of x to the 4th? X to the 2nd. What's the square root of 15? Plus minus. Oh, what's so advanced about that? Oh, well, yes, that's one of the things. Now, here's a little tricky bit. Whenever you factor, you need to look at your remaining factors, or what you got, and say, did I completely factor it? Is this a prime or not? So this one, you may not have enough information to know this, but I'm going to tell you, this one is prime. Sure it is. X squared plus 4 is not the same pattern, right? It's not a minus. What about this guy? Is that the sound of a bell ringing in somebody's head right now? No. No. Oh, yeah, I should be hearing some bells in your head. Yes. Yeah, this one is bell ringer. This one is x plus 2, x minus 2. Now, I can't factor it. It doesn't just go away. So he kind of hangs out. He's one of the factors. But I've got other factors. You can factor this. On the side. Right? Perfect square minus perfect square. So I keep factoring. You keep factoring, so you can't factor no more. You just keep on doing it. Is that much right? It's not. That's why I'm not teaching. Mrs. Marlin said that. She gets a good watching it all over. Makes sense. So that's why it's a little bit advanced. But the moral of the story is always look and see, can I factor more? And if you can, keep factoring. Well, that's not so good. Now, another important point. See important in red? Must be important. There it is. It's important that type 1 does not go away. The first thing you always do, no matter what, is look for a common factor and factor that out. Then you look and see if you can do more. So let's look at this example. You can find it on your paper, right in the middle-ish. Everybody see it? So you look first and say, is there a common factor? Yeah. Yep. So let's factor out the 3. So what's left behind in my parentheses? Go up, 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 up. Bell ringer? Perfect square minus perfect square. So my 3 is still here, but I can factor this guy. What is that? Or if you said x minus 3, x equals 3x. So important, always look. You do this first, do this first. How about these guys? Yes.
Why do you still have 3 in front of the x?
Because that's a factor, right? 3 times this. Because remember, our ultimate goal thing is that when I multiply back, I want to get here. So if I just knocked away the 3, I would only get x squared minus 9. I wouldn't get this back. It's x squared minus 9 multiply sum and differences, I get these, so I'm going backwards. Yep, I'm noticing that, oh, the way you get here is a sum and difference pattern. Now this one, there's tons of, let's say you didn't notice there's a common factor here, and there is, but let's say you didn't notice. Isn't this a bell ringer by itself? Is this a perfect square minus a perfect square? So what do I get? Right? So why can't I just do that? Let's look at these. Can they be factored? Almost. Right? Do you see a common factor in here? 2. So I have to take it out of here. Oh, but wait, there's a common factor of 2 here as well. Take it out of there. Now remember, I'm multiplying, right? These are factors. Well, what's 2 times 2? So if you don't see it at first, you can still get back to where you need to be. However, get in the habit. Is there a perfect, a greatest common factor? Is there? Wait, 4 and 16. I'm just looking at big. Because I don't want you doing it this way. This is like a long way and it's confusing me. There is 4. Take that out first thing. What's left? Right, divide by 4. Divide by 4. What do you have? We got another a perfect square minus a perfect square. Faster, better, easier. This one you wouldn't even know that you could factor it until you took out your greatest common factor. Somewhere on your paper, I actually want you to write the words. Always factor out greatest common factor first. And put some exclamation points around it. Very, 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 very important. I don't care if I already wrote it. You write it. You write it also. Lots of exclamation points. I like that. All right, let's try this guy. Is there a greatest common factor? No. Yes. Right? No, I'm on C. I'm on C. Is there a greatest common factor? If so, what is it? It is 2. Let's see what's left. Divide that by 2. Oh, bell's ringing. Should be ringing in your head right now. Anybody got a bell ringing in their head? Thank you. Is it? What do you mean it's always ringing in your head? Oh, okay, right now. Oh, okay. So what do we get?
2x minus 5 minus x.
That's fine. And don't forget your 2. I think Ken raised an excellent point. You need that too because you want to be able to multiply back to get this. So the 2 is important. Don't forget it. What do you think? Yeah, question.
Will it always have to be a perfect square minus?
Yes, minus. Because remember this pattern is a negative 5 times a plus 5. That's how you get here. It's always going to be a negative. So it has to be exactly that pattern. It's like a difference of squares pattern. So I think we got the U-tries next if I'm not mistaken. So anybody have questions on our U-tries? Yes, ma'am. D. So D, I looked first and I said, is there a greatest common? Oh, this is wrong. Oh, I'm thinking something's wrong on this side. No, something's wrong. There's no X's, right? I solved a different problem. But anyway, yeah, you look for your greatest common factor. It's a 4. Then divide these by 4. I get x squared minus 100. Bell went off my head here because I have a perfect square minus a perfect square. So I open up 2 parentheses. Take the square root of x squared. Take the square root of 100. And it's a plus minus or a minus plus. Wherever you go. Yeah? Now, if you didn't do that, did anybody see it? Perfect square minus perfect square. That's 2x plus 20 and 2x minus 20. Yeah, that's true. But is this the prime factorization? Because I've got 2's here. So those could have come out. Now it's like a lot more work. Okay, another 2 can come out. And I'll get there in the end. But I don't want to do all those steps if I don't have to. And if you don't factor first, sometimes you don't even see that you have it. Like this one, you wouldn't even know that you have a perfect square minus a perfect square until you take out the common factor of 8. Other questions on this? Yes, ma'am. Was that a question? Oh, she's not finished. She's just stretching. Okay, she's down. Okay. Flipping the hair. All right. Let's try type 3. Okay, so a type 3. Now, again, these different types, they're asking you to look for certain patterns. Type 3 is asking you to look for a trinomial. Remember those? 3 monomials. 3 monomials. And then they look like this. You have an x squared. A question over there? Right, x squared plus bx plus c. And what do I mean by the b and the c? They're placeholders for numbers. So x squared plus 5x plus 6 is an example of something that fits type 3 patterns. It's a trinomial with a leading coefficient of 1. Okay. So this is an example of a trinomial that we want to factor. To do these, you have to answer this question. What do you multiply to get this number? And what do you add to get that number? Because what we're doing here is we're doing a reverse FOIL. And I'll just put some letters here to remind us about FOIL. Right? How do you get this thing? You multiply b times b. And how do you get the middle number? It's that times that plus that times that. Plus. So a multiply gets us here, and a plus gets us here. So let's think about it in a more organized way. So actually, let's go back here. What numbers do you multiply to get 6? Please don't shout out. I want everybody to have that chance to think about it. What 2 numbers do you multiply to get 6, but add to get 5? What do you think? 2 and 3. So that's who's going to help us. Awesome. And if you're having trouble seeing that, don't worry. We're going to work a little bit on that. So we're going to do a little puzzle here. These ones aren't on your paper. I want you to find me. Again, raise your hand when you think you know. Don't shout out. 2 numbers that multiply to 4, but add to 4. They also add to 4. How do you see it? Emma. 2 and 2, right? 2 times 2 is 4. 2 plus 2 is 4. How about 2 numbers that multiply to 12, but add to 7? 2 numbers that multiply to 4 and add to 7. What do you think, Andrew? 3 and 4. And make sure it works. 3 times 4 is 12. 3 plus 4 is 7. That's the multiply and add. I should do that again. Let's try another one. I want 2 numbers. Look at those. Hands are up already. 2 numbers that multiply to 9 and add to 6. What do you think, Kaylee? 3 and 3. 3 and 3. 3 times 3 is 9. Okay, now, there are 2 kinds of people in this world. There are people that look at it and dang, they know it. And there are people like me, when I was in your position, when I first saw this, I was like, what? Where you have to think about it a little bit. Now, what is the thought process that some of your brains are just kind of automatically doing? I'm going to go back to this one. What you do is start with the multiply. Think of all 2 numbers that multiply to 12. 1 and 12 multiply to 12. 2 and 6. And 3 and 4. Now, I need ones that multiply to 7. No. No. Yes. So some of you have brains that do that at lightning speed. You don't even know that you're doing that. Some of you may need to kind of actually write it out and look. Doesn't matter. You're not a better person if you're one or the other. Okay? It's just how it works. So we've got a few more. These ones are on your paper. So again, if you think you know, you can raise your hand. Claire? What? 3 and 6. 2 numbers, they multiply to 18, they add to 9. Let's see, I need 2 numbers, multiply 24, that's 14. What do you think, Alex? You guys are really, really fast. Somebody who's not as fast as this, you're getting a little lost. You okay? Please ask if you need a little hard. Because I think they can be a little hard at first. Let's see, I need 2 numbers, multiply to 30, and add to 13. 2 numbers, and everybody a little bit of think time. Katie, what do you think? 2 numbers that multiply to 30, but add to 13? Good job, Daniel. She's taking it back. Well, let's do this one a little bit slower. Let's think of all the numbers that multiply to 30. There's 1 times 30. There's 2 times 15. There's 6 times 5. There's some more, though. 3 times 10. Any others? Okay, so Katie, which one of these are going to add up to 13? So if you're not kind of, I mean, believe me, when I was in your spot, I did not like this doing this. So I had to think about it. Think about all the factors and which one works. Now I'm going to try something else here. We got some negatives in here. A little extra thought here. Two numbers that multiply to this negative 24, but add to 5. And before you raise your hand, if you have a negative number, what do you know about the signs of the two numbers? Right. The only way to get a negative number is one is positive and one is negative. If you add a positive and negative number, what's the logical operation really doing here? You're subtracting. So when you have a plus and a minus, you're looking for two numbers that multiply to negative 24 but subtract to 5. So if you're looking at factors of 24, which I'm just right now, this time you're subtracting to get here. So Ishan, which ones work? Well, it's 83, right? Because they subtract to 5. Who's negative, who's positive? Well, it does matter. Why does it? Let's just pick. Well, let's pick this. When you add these two, do you get negative 5? No. So it does matter. If this is negative, kind of the bigger magnitude number gets negative, do the add just to be sure. A very, very common mistake is to have the signs wrong here. So multiply up, add back. All right, now I've got, this is negative. I'm multiplying to negative, and I'm adding to positive. But what are my signs? Opposites, right? Have to be. Two numbers that multiply to negative 15, and those two numbers, in essence, are subtracting the 14. So they're going to be very easy to divisible. So 15, negative 1, they multiply up. 15 plus negative 1 is 14. If you by mistake put the plus 1 here and a negative 15 here, try to test it through the add just to make sure. And now I've got a positive up here and a negative down here. Come on. Right. If you have a positive number up here and a negative down here, the only way to multiply to a positive is they're both positive or they're both negative. But since this one has to add to a negative, they both have to be negative. So you need an add. She said, well, 7 times 4 works for both. Who's with me? Who's with me? Who's got a question? Who's got a question? Yeah.
I got instead of just
Well, I mean, the way, I don't know if it's easier, the more methodical way is to figure out what are all the two numbers that multiply to that top number and see which one works. Because sometimes, you're right, I mean, it doesn't always pop in your head right away. So you just figure out, well, what are the factors of 30? And we used to do this, I don't know if you guys still do this, we would build little sets. There's 1 and 30. There's 2 and 15. Did you guys not do this? There's 3 and 10. And I got also 5 and 6. So I can kind of build out a little set and I know what two numbers all multiply to. See, it makes sense. We had to do that for a reason. Now we need this little skill because to factor now. It's very simple if you can do that. So I'm on the back here. And we're going to go step by step. First is always recognize it's type 3. X squared plus bx plus c, and it is. That's a type 3. You draw two sets of blank parentheses just like we did with type 2. Okay, we're reverse spoiling, right? So if I'm multiplying two things and I get an x squared, how can I get there? Well, one has to be an x and the other has to be an x. So draw your parentheses, x and x. Then what? Then you play the game, right? It's like a little game here. Well, and what you have to remember is, this is what you multiply to, and this is what you add to. So if you're going to make this little guy here, the 2 goes up top, and the 3 goes on the bottom. Or you can just do it in your head. What two numbers multiply to 2, and that's it. What are they?
I just have I did type that.
You did? Where'd you go in 4th grade? Who did that?
I don't know.
In Loudoun County?
Yeah, like we had like this little flashcards, like there's a side thing.
Oh.
We went to the dump.
Oh.
And then
Yeah, all right. Well, that's awesome. Then this should be easy. Because what happens is once you find those numbers, if they're positive, put little pluses here. Because you know what you're going to do? You put the plus 2, you put the plus 1. It is factored, multiply to verify, do a FOIL, and you get back to where you were. Can you say x plus 1? X plus 2? Yes. So if you had the 1 here and the 2 here, they both work. You did it properly. And I believe we've got some examples, so some more examples. So let's try it again. So I've got the rules kind of listed out here. So first of all, I didn't mention, but you should have noticed that it's type 3, meaning it's a trinomial. First coefficient is 1, x squared plus bx plus c, type 3. Okay? And so first thing you do is you draw two sets of parentheses. The next squared, so it's always going to be x and an x. Then you say, what multiplies to this but adds to that? Two numbers that multiply to 6 but add to 5. What you got there? 3 and 2. And these are positive numbers, right? So positive 3, positive 2. Did you say x plus 2, x plus 3? Absolutely, either way. How do you verify? And again, you don't want to skip this step. I still do it. I do it in my head now, but I still do it. So you do x times x times 3, 2 times x, 2 times 3, add the middles. Works. Right? They match. And that's it. That's type 3. That's all you gotta do. That's not hard. Well, let's see. Let's try some other examples. So I'm recognizing it's a type 3. X squared minus 6x plus 8. It matches x squared plus bx plus c. And so I draw my two sets of empty parentheses. Because it's an x squared, it can only be an x and an x. I want to multiply to 8 and add to negative 6. All right? Since this number is positive and this number is negative, what do I know about both of these guys? They both have to be negative. Now I need two numbers that multiply to this but add to that. Put it in, Taylor. Negative 4 and negative 2. And test it. Negative 4 times negative 2 is 8. Negative 4 plus negative 2, negative 6. So negative 4, negative 2. So the minus signs are kind of taken care of. Let's verify. So that's x squared minus 2x minus 4x, negative times negative plus 8. Combine the OI. Do I get what I started with? I did it right. Question?
So the variable in front, you put that as the blank minus the plus squared.
The variable of what do you mean?
Like the x squared, you x is plus x.
Yeah, the x squared is the x times the x. Right. Yep. Okay, so a couple more examples here. So let's see, it is a type 3. So I'm going to draw my two sets of parentheses. Put in my x times an x, because x times x is how I'm going to get my x squared. And I want two numbers that multiply to this last number, but add to the middle. I don't see a middle. It's implied, right? A negative x is the same as a negative 1x. So two numbers that multiply to this, negative 2, but add to negative 1. You got it, Alex? Negative 2. Right. Now let's just remind ourselves, because this one's negative, I have to have a plus and a minus, right? Different signs. It's subtraction. All I got is 1 and 2. And that works. 2 minus 1 is 1. But how do you know who is positive and who is negative? Now how do you know that? I mean, you're right. How do you know? Well, it's more the add, right? Because that says I can make the 1 negative if I wanted to. Why can't I just do this then? If I'm just multiplying. I want to add that, right. So if you were to add a 2 and a negative 1, you get a positive 1, so you know that's not the right one. So especially with pluses and minuses, just check and make sure you got them right. And then put them in as written. There's the plus 1. There's the minus 2. Definitely verify these guys. Again, the most common mistake is you mix up signs. So there's your x squared minus 2x plus an x minus 2, x squared minus x minus 2. It matches. All right, so this one, the type 3, I want to multiply to this number, and I want to add to that number. So I need two numbers that multiply to negative 15 and add to 2. Again, because this is negative, I have to have a plus or a minus. A coin. What you get?
5 and negative 3.
5 and negative 3. Let's make sure we have the signs correct. Certainly works when you multiply up. 5 plus a negative 3 is 2. So we made the correct one positive and the correct one negative. So we go ahead and draw our little brackets there, our parentheses rather, x and x, plus 5 and minus 3. of 5x. And I get right to my 2x a little bit faster. Minus 15, and they match. You're not ready to be doing it in your head? Don't do it in your head right now. What do you think? Who's that thumbs up? Why is there one person? Good, good. 1, 2, 3, 4. You know what? Shh, no problem. Just give me 1, 2, 3, 4. Everybody, everybody!
Is 3 being the best?
4 is the best. 4! Wow!
Wait, how did you bring that?
He's changing his mind. I'm going to go 3, but that was too big a wow. Alright, if you're a 2, that's okay too. I hope you're not a 1. If you're a 1, we need some questions. Now, anybody have a headache yet?
Yeah.
Alright, wait a second. Sometimes I have the greatest common factor, and then this type 2 business, what's that again? And now I've got type 3 business, and it's like, I wish there was some way to help me organize my thinking. But there is. There is. It's called a flow chart. I have a little flow chart to give you, which helps you factor, helps you ask the questions. Now, unless you're a software engineer, anybody here a software engineer? You are. So you know what a flow chart is.
Sure.
Okay. Most people don't. Most people don't. So I brought in the experts to help us.
We don't have to do hard. Sorry, people are watching at home. We don't do this.
Okay, so here are some polynomial equations that we need to solve. It's the same process, dare I say algorithm, now that we know what flowcharts and algorithms are. Same thing. Put all the terms on one side, 0 on the other. Factor what you have, set each factor equal to 0. I know it's after lunch, I know you're sleepy, but I do need you to look it up here. I do need you to really pay close attention. So again, I can't just solve this by subtracting out the 12, dividing by 8. It doesn't work. So all my terms are already here, and 0's here. So I'm going to factor. Now I have to figure out how to factor. According to the flowchart, the first question is there a common factor? Nope. Is it a difference of squares? Does it look like a squared minus b squared? No. Is it a trinomial with a leading coefficient of y? Yes. This is a type 3. How do we factor type 3? We make our 2 parentheses, and notice my equal 0 is still here. I'm solving an equation. X and x. I need 2 numbers. They multiply to 12, but they add to 6. What 2 numbers multiply to 12, but add to 6? 8. What would it be? What's it going to be? 6 and 2. Plus 6 and plus 2, right? Does that work? They multiply to 12 and they add to 8. And I would do an x, that's an x squared, a 2x plus a 6x is an 8x, 6 and a 2 is a 12. And that was my check. I checked that I did this right. Okay, then what? Use the zero product property. Is this times this equals 0? So it could be that this is 0, or it could be that that is 0. Solve both of these equations. Subtract 6. This one we subtract 2. And now I have found the solution. Now this gets back to the question you guys asked earlier. Is it always going to be one of them going to be 0? So is one of them always going to be 0? No. Could be sometimes, but not here. Right? Okay, let's try this one. First step is, are all my terms on one side? I gotta move that guy over. Yeah. They're both the answers. There's 2 solutions. If you plug in -6, you get 0. If you plug in -2, you get 0. Now, you probably don't remember, but when we graph these things, the last class, it looks a little like this. And what am I really finding? I am finding roots, or zeros. So I'm finding 2 things. So it makes sense with a quadratic that you will sometimes have 2 solutions. Yes. Right. How do you tell me what the answer is? You can do this. I'm okay with this. And if you want to put it in a solution set, that's great too. These are all ways of expressing what the solutions are. Okay. Coming back up here, I'm subtracting that 18. Again, and I'm just going through the flow chart just to practice it. Are there any greatest common factors? I always do ask that first. Are there any greatest common factors? I don't see anything. Is it a difference of squares? Is this a type 2? No. Is this a type 3? Yes. So that means we make our 2 parentheses. X times x is the only way to get to x squared. Now I need 2 numbers, and sometimes it may help to make this whole thing. I need 2 numbers that multiply and negative 18, or that's a 3. This is negative, so I know I'm going to have a plus and minus. So I know what to subtract. Yeah, what'd you get? Negative 3 and 6. Let's make sure we have our signs in the right place. 6 plus negative 3 is positive 3. So one's a plus 6 and one's a minus 3. I have now factored. So I have two factors that multiply to 0. So it could be that this guy was a 0 or this guy. So x is negative 6 or x is 3. Two solutions will work. Plug a negative 6 in, you're going to get 18. Plug a 3 in, you're going to get 18. You can verify it that way. And I do that a lot too if I'm not quite sure. I use my calculator to help me sometimes. And now it's a different question, but I think Quinn pointed out that this is really the same question. So Quinn, how am I going to set this up? F of x is x squared plus x minus 20. How can I find the zeros?
X squared plus x minus 20.
Excellent. Okay. Is there a greatest common factor? Nope. Oh, sorry. No. Well, 1, yeah, other than 1. Right, 1 doesn't help us if I'm going to factor it out. Is it a difference of squares? Is it an a squared minus a b squared? Right? Now remember, that's only 2. That's a binomial. It's a trinomial. Can't do that. So here's my type 3. So I'm going to break it into my cube parentheses. X times x is how you get x squared. Now I need two numbers that are going to multiply to negative 20 and add to what? 1, right? The invisible 1 is sitting there. So let's see. It's going to be a plus and a minus. Now one person sees, I'm going to give you just a little bit of think time so everybody can think about it a little bit. Two numbers that are going to multiply to negative 20. But when you add them, you get 1. And it is. I mean, I think they're kind of fun. It's like a little puzzle like this. If you're having trouble, write out the factors of 20. So you got 1 times 20. You got 2 times 10. You got 4 times 5. I think that's it. Do any of these things subtract to 1? The 5 and the 4. And now you got to figure out who's the plus and who's the minus. The 5 is the plus because, you know, my 1 is positive. So the bigger number is going to be the positive. So that's a plus 5 minus 4. Now I factored. So I'm going to set each factor equal to 0 and then solve those equations. So x is negative 5 and x is 4. Plug them in if you want to check. Not a bad idea. What do you think? All right, well, we'll find out in a moment what you think. We're going to do some retries. Okay, really good question. What is this asking? When it says factor, what am I asking you to do? Factor, exactly. I have a lot of people tell me x equals 1. I don't know, it's not an equation. It's not an equation. I'm just asking you what 2 or 3 or 4 or 5 polynomials will multiply to that. You did this one correctly. You got x plus 3, x plus 1. That's factor 4. You're done. Now this is solving an equation. Solving an equation is different. Now you are still going to factor it, but then you've got to equal 0. Oh, okay, what is that going to be? 24 and 1. Okay, so what is this one? Now you're solving an equation. You receive the difference between factoring and solving. Very subtle difference. Factoring just says what times what gives me that. Solution, right, says solve the equation. I need to do this to find the solution. Yes? Question? How did you get 24? Let's see. I need two numbers. Whoops, 23. Now multiply the negative 24 and add to 23. And I thought about everything that multiplies to 24. 1 times 24 doesn't work. Yes, it does, because this is going to be a plus and a minus, so I'm subtracting. Right, because there's a whole bunch of different things I could have tried. And they said, who subtracts the 23? This one. Because this is positive, the 24 goes here and the negative 1 goes there. I did it fast because I've been doing this for about 26 years. At least, it feels like it.
Can you open the door to the side on the top? Are you doing this? Can you do on the top?
Well, now I'm solve an equation. The reason I do factor is to solve an equation. I didn't give you an equation here. There's nothing to solve. I just want you to factor it. It's like saying, what's the factors of 6? 2 times 3. That's all I'm looking for. On the top. If I say factor, that's all I want. If I say solve, I want x's that make it true. Yeah. Okay. Roots is solving an equation. Got a set of roots. So you just add this over to get an equation. And it says, find these roots. Roots and solutions are very similar. They're almost exactly the same thing. So it's just another word, and I wanted to put the vocabulary in there so we see it and know what to do. Zeros, what does that mean? Tell me what point on the x-axis will this thing cross or touch? How do we find zeros? You set y equal to 0, or you set f of x equal to 0. What do you think? So you're just going to take this guy and set it equal to 0. You're going to take this guy and set it equal to 0. So yeah, they do seem like the same thing. We're just getting used to the questions that this answer. Right? Does that help at all? Yeah. I mean, I know it's confusing. I know. It's gonna come together. Just like you did up here. You'll look and see. Are there any grades common factors? Nope. I don't see any. Is it a difference of squares? Is it an a squared minus a b squared? No. Oh, it's a type 3, right? So I'm going to factor it. X and x. I need two numbers that multiply to 36 but add to negative 12. Since this is positive and this is negative, I know they're both negative. What two numbers multiply to 36 but add to negative 12? And think of all the factors of 36. 1 and 36? 2 and what is it? 66. So minus 6 minus 6. What's x? Right, you're going to set this equal to 0, set that equal to 0. These are the same. So what's x? Opposite 6, right? X minus 6 equals 0. Add 6 to both sides. This one has only one solution. Remember, with these I can have two solutions, one solution, or no solution. At the moment, I'm not giving you any that don't have at least one.
So finding the root is doing
Solve the equation, right? Solve this equation. You're factoring, which is the x thing, to help you solve the equation. Okay, I'm going to go see if I could answer them on the last one. You're not going to be able to read it. I'm going to get rid of some of my scribble. So you can look at those and see how you're doing.